In this lesson, we're going to talk about trig identities. A trig identity is some sort of trig equation that's true for any value. Okay, these are really useful in solving more complicated problems. We have a handful of trig identities here in the notes, and next year when you take trig, we'll get even more of these. Now, right now, these are things that you do not need to have memorized. They need to be things that you're familiar with. So I want to kind of walk you through some of what these are saying. The first we have is our reciprocal identities, and you should kind of already know these. Cotangent is the reciprocal of tangent, and likewise, tangent is the same thing as 1 over cotangent. Okay, so those are the reciprocal identities with tangent and cotangent. Cosecant and sine are reciprocals. So cosecant is 1 over sine, and that also means that sine is 1 over cosecant. And secant and cosine are reciprocals. So secant is 1 over cosine, and the other way you can write this is that cosine is 1 over secant. All right, the next one are our quotient identities. Tangent is sine over cosine. That's one that we do use a lot. I'm going to circle that one because we use that a lot. And then since cotangent's the reciprocal, cotangent is cosine over sine. The even and odd identities, what this says is that sine of negative x is the same thing as negative sine x. And that is the definition of an odd function. Now, if you remember way back first semester, we talked about odd functions. Odd functions have origin symmetry. And if you think about the graph of sine, it looks like this. It does have origin symmetry because if you take it and rotate it 180 degrees, it's the same thing. Tangent is also an odd function because if you take tangent of negative x, you get negative tangent x. And again, if you think about the tangent graph with all of the seaweed, if you think about rotating the whole thing 180 degrees about the origin, you're going to get the same thing back. Cosine is different. Cosine of negative x is cosine x. That means cosine is an even function, and even functions are symmetric about the y-axis. So remember, cosine starts at the crest, and you can see that this has y-axis symmetry. Okay, so that's why they're called the even and odd identities. The next three that we have are called Pythagorean identities. They look a little bit like Pythagorean theorem. This one, we call it our favorite Pythagorean identity because we use it the most, that sine squared plus cosine squared equals 1. Just a little note on this, sine squared theta, what that means is you're taking the sine of theta and squaring it, okay? Those mean the same thing. We just tend to write it as sine squared theta, so we don't have to write parentheses all the time. The second Pythagorean identity is tangent squared theta plus 1 is secant squared theta. And the third one, which we use probably the least often, is 1 plus cotangent theta squared is cosecant. And then the last little section is cofunction identities. We don't use these real often. I don't think we're going to use them much this year. But it is saying that the sine of pi over 2 minus theta is the same thing as cosine theta. All right, so let me show you how we actually use all of these in context. So we want to simplify these expressions. I'm just going to start with these first two. So to do that, the first thing that we want to do is let's think about tangent of negative x. Looking back up here in our table, tangent of negative x right here, tangent of negative x is the same thing as a negative tangent x. So we'll replace that with negative tangent x. We still have that cosine x. And then if we think about tangent over here, the one I circled, tangent is sine over cosine. So now let's change that tangent, changing this thing. So we still have that negative. Tangent is sine of x over cosine of x. Okay. Maybe I'll underline these in pink. Okay, so the first thing we did is we changed that, and then we worked with that. Okay, now what we're going to do here is we're multiplying fractions. This is cosine over 1. Remember, when you multiply fractions, you're allowed to cancel things on the diagonals. So these cosines cancel, And our answer is negative sine x. Okay, so that's simplified. Okay, let's try another one of these. We're going to start with sine of negative x and tangent of negative x. So we're going to look up here. Sine of negative x is negative sine x. Tangent of negative x is negative tangent x. So I'm going to replace both of those. So that's negative sine x times negative tangent x. Now, the negatives are going to cancel each other out, so I have sine x times tangent x plus cosine x. And now what? Well, let's try the same thing we did over here. Let's change that tangent. Remember, we said tangent was sine over cosine. So we have sine x times sine x over cosine x. All right, so I'm multiplying fractions over here. Now, I'm only allowed to cancel on the diagonals, and I don't have anything on the diagonals, so I'm going to keep doing this problem here. So on top, I have sine times sine, which is sine squared x. And on the bottom, 1 times cosine is cosine, plus cosine x. And I'm going to go ahead and put that over 1. Okay, I want to add these fractions because we're trying to simplify it, get it all down to one thing. So to add fractions, I need common denominators. My common denominator is going to be cosine. So in this equation, I'm going to multiply top and bottom by cosine. That's going to give me common denominators. So I have sine squared x over cosine plus cosine squared x over cosine. And now, since I have common denominators, I can combine that all into one fraction. Sine squared x plus cosine squared x all over cosine x. All right. Oh, I see it now. Now look at your numerator. Okay, remember how I said we had a favorite Pythagorean theorem? So our numerator is sine squared plus cosine squared. Well, sine squared plus cosine squared is 1. So our numerator is 1, and our denominator is cosine. And we are almost done here because I know right here that 1 over cosine is secant. So, oh, sorry, that was a mistake. I didn't mean to touch that. So this 1 over cosine is secant x. And that is our answer. Okay, so this thing here simplifies to secant x. Now, these things take practice. It's like doing a jigsaw puzzle, okay? The more you do them, the better you're going to get, but it just takes practice recognizing what you should do and when. So I'll walk you through the next couple examples in the next video.